Hi everyone, welcome to this video. In the previous video, we discussed about log and time complexity. So just to give a refresher, what is log and time complexity? In log and time complexity, you search an element in a list or an array given. So for example, let's say this is my list and 1, 2, 3, 4 and 5. So what do? We search an element inside a list using left pointer and right pointer, and by splitting the data into half multiple times till we reach uh, our desired result. Okay, so for example, let's say I have to search an element 4 inside this particular list. So how will I do? I will assign a left pointer and I will assign a right pointer. So once I do that, there will be a mid pointer which will be 3 here. Okay, and the condition is that if my mid pointer is less than my target, then what do? I shift my left pointer towards mid plus 1. Okay, so this will become my new left pointer. After that, I will again split this and I will again check. This will become my mid pointer, and eventually, so for example, what will happen? This will be my 4 5, and this will be my left pointer, right pointer, and when I do a mid pointer, this will come as my midpoint as well. Okay, and now because mid is equal to target, I'm good with it and I will return my result. So this is how things are done in binary search, you say, or log and time complexity. The sole objective or the core objective of the method behind log and time complexity is that you split data into half till you reach your desired result, and that's why you can achieve complex task with complex or big data set. For example, we discussed this. If you have a billion number elements in your list, then also it will take you only 31 steps to arrive at the result, and that's why this was very it was very good method to do this. But the biggest drawback of log and time complexity is that your data needs to be sorted. If you see this particular case, this data is sorted, right? So this is the must, you say, for a binary search, that your data needs to be sorted. If your data is not sorted, binary search fails and it will not work. So we will look through an example that why does it happen that binary search does not work with unsorted data set. So let us say this is the scenario where you have a list of 5 elements and this particular data is unsorted, correct? And let us assume we have to search a target which is 7 in this particular case. So how do we do using binary search or log and time complexity? This is my left pointer and this is my right pointer. So what do? I take the middle element. So this will be my middle element. Now, if you remember, the condition is that if my mid element is greater than my target, correct? So it means, so what does it mean? That if my mid element in the data set is lying somewhere here, technically it means that, and my target is lying somewhere here. So what do? I shift my right pointer from here to here. Okay, so this is the if condition that we used to do in binary search. So what will happen? You will move your right pointer from here to here. So 3 will become your new right pointer. Now technically you have to search 7, but you are already out of the scope of 7. You are in 10th. You are now only left with 10.3. Now let's say you further do the search with 10.3. What will happen? That you'll further split it. This will become your new left point. This will become your right point, and this will further become your midpoint as well. Okay, and because again your midpoint is greater than your target, which was 7. Okay, you will again move your right pointer from this to here. Now here technically means your right pointer has become -1 now, which is out of bound, which is practically not possible, and this code will give you an error. So this is the reason that your binary search or log and time complexity does not work with unsorted data sets. You have to sort the data before. Now, how to achieve this particular task? For example, let's say you have to locate an element in an unsorted array. So the best way to locate an element in an unsorted array is simply to use the most simple method, that is called n time log. So I mean to say linear time complexity. So let's say this is the data set 73114. Okay, so how will you do that? Let's say I have to search this. I will simply use O n time complexity. And if you remember the chart, that how you used to have the log n time, O log n time complexity. This was my log n time complexity, and this was my linear time complexity. But a scenario where what we need to do, what if we need to know how shall I sort my data set? For example, if I have to convert this list into 1, 3, 4, 7, this is called sorting, right? So how do I sort it? Now, to sort this particular list or any data structure, there is a set standard of methodology that we follow, and that is generally called merge sort algorithm. There are other type of sorting algorithm as well. Just for example, quick sort, there is bubble sort, there are, which we'll be discussing in the later videos. But all these sorting algorithms, they work in nlogn time complexity. Okay, we will discuss what is nlogn in few minutes from now, but just try to understand the sorting. So for example, in list, you see this method sort. For example, you have a list, we generally do list dot sort. So what is the backend of this particular sort function? This sort function works on merge sort algorithm, and this is nlogn time complexity. And where does nlogn time complexity stand here? Nlogn time complexity stands somewhere around here. So it is not a very efficient algorithm, but sorting can only be achieved using nlogn time complexity. There is no better approach to sort an algorithm than nlogn time complexity. So we'll discuss this in more detail once we start the algorithm part. Right now, just focus on that we are trying to understand nlogn time complexity. And why do we need to learn it? Why we need to learn it? Because to sort any data set, there is no better algorithm than this. And even though the time complexity is not good, but I mean, we have no other option. It's just like beggars are not choosers. So that is the point. We don't have any better time complexity than this. So now let's switch towards discussing the general architecture of nlogn time complexity. What does it intuitively mean? And we will try to visualize this through an example. In this video, I'm not going to code through it because the coding part is little bit more advanced for this particular time complexity. So we will take care of that once we start discussing sorting algorithms. Right now, just focus on the logic, how we are achieving nlogn time complexity. What does it actually mean? What is n? What is log n, right? So those things we will be discussing now. So to understand nlogn time complexity, let us say we have this particular array which has 8 elements, and this array is unsorted right now. So this particular task of sorting is achieved in 2 steps. Remember, there will be 2 steps in any sorting algorithms. So if you see, there is nlogn. So first of all, let's break this. Nlogn is technically a combination of on multiplied by log n. Okay, that is why it is called as so it is a combination of O and n and log n. So if we have to recall, what is n? What is on? When on, you basically scan each element in a list, correct? If you remember, scan each element in a list. That is the meaning of on, linear time complexity. Scan each element in a list. That's what we used to do. And what we used to do in log n, we used to split data into half. Split data into half till I achieve my result. So to sort any particular data set, we need to follow these 2 steps, and that is why, and because these 2 steps happen simultaneously, that is why this particular algorithm is known as nlogn. Okay, now let us try to break this particular thing. Let's try to understand each step in detail. So as I mentioned, there will be two steps involved. One step will be to split your data set into half, and again will be to visit each element in your data one by one and do some steps. So how, first of all, let's try to look from an overall perspective. How do we do this? So the part one is in sorting algorithm is log n part. What do we do in log n? We split data into half again and again till we reduce the list into individual list of one element each. So split your given list into half till you achieve list of one element each, or till you achieve lists of one element each. So for example, in this particular case, let's say you have to split this. So what will you do? First of your first split will be done like this, okay, here, and second, so this will be the left part, this will be the right part, okay. So what will you do? And after that you will split it again from here. You will have this part, and then you will split again here and here. So in total 3 splits, you will be able to reduce this particular list into individual list of one element each. So you will be having something like 38, 27, 43, 3, and so on up to 5. So what you will have, you'll break it into 8 lists. So, or you can say n lists, depending upon the size of your data set. You will break it into n lists. Each list will be having one element each, okay. And this is the log n part of this particular algorithm. And once you have achieved this, your second part is to merge individual components back so that you can basically sort it back. So for what do you do? For example, let's say you split it like this, 38 and 27. So you will first of all take these two as a group, and then you will sort them. So what will happen? You will get 27 and 38 because you have sorted them. So let me just show once again. So let me just clear it once again to just explain you what do I mean. So what will be happening here? Initially what you did, you took your data, you split it into multiple lists. So 38, 27, 43, 3, 9, 82, 10, and 5. Okay, you have splitted it in this. Now what you will do, you will pick two elements each. First of all, you will pick these two, you'll pick these two, you'll pick these two. Okay, and then you will first of all you will sort these two elements inside it. Okay, how this sorting is done? So sorting two elements is simple. It's simple, like it will happen in one step, right? So what it will convert it into 27, 38. Okay, and now we will use this. So 343, if you sort this, it will become 343. Okay, now when you sort 982, it will become 982, and then it will become 10.5 will become 510. So that's how you have sorted individual. Now what you will do, you will pair up these two. Okay, and you will pair up these two, and now you will create a new basically list out of this which is sorted. So what it will become now? It will become 3, it will become 27, it will become 38, it will become 43. Okay, and then again you will have similar method you will do here. So it will be 5, 9, 10, 82. So you are left with 2. Now you will finally same step you will follow on this, and what it will become? It will become 3, then it will become 5, it will become 5, then it will become 8, then it will become 9, 10, 27, 38, and 43, something like that. So what has happened here? First of all, there are 2 steps which are involved there. You first of all broke whole list to split the whole list into individual chunks till you come to the base form of one element each, then you keep picking two elements and go up, then you pick again the two elements, then you go up till you reach back here, and that's how this particular sorting is done. So let us try to understand it, that how this particular sorting happens, or how do we select elements. Let's try to understand this in more detail. So let us first of all understand how the chunking happens, okay, or you can say splitting happens. So let's see that first of all. So what will happen, and this is the step one, which is your log n part. So how do we split the, so we'll see each step one by one. So first split will be made use at the center, okay. Then you will be having this particular list, which is, so you'll have one list here and you will have one list here, okay. So there are four elements in this, 1 2 3 4. So one will be, this is will be 38, 27, 43 and 3, and this will be 9, 82, 10 and 5, okay. Now we will again split this particular thing. So now this will happen on this thing. So you will be left with 38, 27, then you will be left with 43 and 3, okay. So this is 43 and 3, and if you split this, it will become 9, 82, and it will become 10 and 5. Now we have to keep splitting till we reach list of one element each. So we will further split all this, okay. So now once we split this, what will be left with 38, 27, then we'll be left with 43, 3, this will be 9, 82, 10 and 5. This will be my remaining. So now I have completed the splitting part. Each of the element, my whole list has been splitted into individual list of one element each. Now comes the next part, where I have to merge these elements back together to combine to create a sorted list. So how that is done, let us see, and based on what order. Remember the order in which we splitted this element, okay. So now we have to go from here to here. So it cannot happen that I pair up 38 with 9. I have to go in that particular order only in which I split it. So for example, now let us say I am talking about the second part, which is n, where, so what will happen, I will have to technically go through each of the element and come back again, and that is why this is n, because you have to access each element which has been broken down into single element again and again. So what will we do first of, so how the pairing will happen? The pairing cannot happen, as I mentioned, 38 and 43. We see that at one level above it was 38 and 27, okay. So this will pair up in this order only. So you'll pair up like this only, 38, 38, 28, sorry, 38, 27, 43, 3, okay, and 9, 82. This is how your pairing will happen, and 10, 5. So this is how you have created pairs. I hope you understand how we did this. Now let me just move little bit. Now I have to technically come down. For what I have to do here is, in this particular part, first of all, I have to sort each of the elements. So earlier it was 30, 27. So what it will become? It will become 37 and 27 and 38. Okay, 27 and 38. This particular part will become 3 and 43. So 3 and 43. This particular part will remain as 982 because it is already sorted. 982. And this particular part will become 5 and 10. Okay, so we have reached to this level. Now if you see 3827 and 343, they were the part of the, if you see, they were part of this 30. So these four need to be together first. So when you will join, you will be joining these two first of all. So when you'll be joining back these elements, you will be clubbing these two together first. Okay, so remember the order in which you split it, it is the same order in which you will merge them back. But the only difference is that while merging, you need to start sorting things one by one. Okay, so that's how it is done. Now, if you come back here, how this sorting will be done is that now you have this particular part. So now once you combine this particular list will become, if you see, so 1, 2, so this will become 3, 27, 38 and 43. Okay, and this will become 5, 9, 10 and 82. Okay, now we are left with two lists. So we simply have to merge them together by sorting. So the final list will look like 1, 2, 3, 4, 5, 6, 7 and 8. So it will be, so when you have to sort them, so see, it will become 3, 4, 5, 9, 10, 27, 38 and 82. And this is your final sorted list that you have created. And because you accessed each element while merging back, you accessed each element again, like the whole list of n elements. That's why this merging part is of n time O(n) time complexity, and combined whole algorithm becomes nlogn. So what happens that your sorting, first of all, what you do, you split. Okay, the splitting happens in log n time complexity, and merging back happens in O(n) complexity. So the combined total algorithm for your this whole sorting process is nlogn. So depending upon the size, as your data set, if you see, as your data size increases, as your n increases, the number of steps required to split it into base form increases, and the number of operations required to access each element while merging back, it also increases. That's why there is a multiplication nlogn. And this is the whole algorithm, how this particular algorithm works, that you take two elements, you first of all take a whole list, you first of all reduce it to base form. Okay, then you start reverse engineering. So just to give a thing once again, what we did, we had this list at the top. Okay, we first of all split it into two parts, then again into 4, then into 8. Once we have achieved this, we will start merging back things together while sorting. So we'll merge them together while sorting, merge them together while sorting, and we will reach here till we have actually sorted the whole list. And this is the whole intuition behind using the merge sort algorithm. Now you will ask that, for example, how this sorting happens. For example, let us say I am having this 38, 27 and 43, 3. How do I create this sorted list out of this? So let us discuss that part now. That let's say we have 38, 27 and 43 and 3. So let us say we have 38, 27 and 43 and 3. 43 and 3. So how do I create a sorted list from these 4 elements? So pay very close attention to this. What we do, first of all, we do assign a pointer. So this will be the first pointer to this particular list, and it will be the first pointer to this particular list. Okay, so how we do that, we first of all compare the we compare these two numbers, 38 and 43. Whichever number is smaller, we basically add it in my final list. Let's say this is my final list which I'm creating. Okay, so what I'm doing is that right now I'll be comparing 4 numbers with each other. That is why this is of n time complexity, because we have to access each element to compare and store here. So how it will happen, first of all, I'll compare the first element of both elements. So let's say 38 and 43. The 38 is smaller. So what I will do, whichever number is smaller, I will put it here in the list first. So let's say this is 38. Okay. Now, so before this number needed to be sorted. I'm sorry. So this cannot be 3827. This number needed to be sorted first of all. So let's say this was 27, 38, and this is 3 and 43. Okay, this number needs to be sorted first. 3 and 43. So how do we achieve here? For example, so what we do, first of all, once we have splitted it back, once we have created something like this, once we've reduced it to base form, first of all, we will take these two and sort them. Once we have sorted them, now we have to get this particular final list. So these two elements need to be in sorted part. So how do we do that? We'll compare first element, whichever number is smaller, it will come to my final list first. So between 3 and 27, 3 is smaller. Now because I have used 3, I will move my pointer from here to here. Now this will become my pointer here. Okay, now I will compare 43 with 27. Now between these, 27 is smaller, so I will add 27 here and I'll move this pointer to here. So now this number is gone, this number is gone. Now between these, comparison will happen. Whichever number is small, it will come first and the remaining number will come next, right? So just by comparing, accessing each element one by one, we are able to create this particular list. So this is the basic intuition behind, as I mentioned, log n time complexity, that how do you merge and sort things. So just I will give a quick summary of all this once again in a new sheet so that you guys can understand once again. I'm doing this once again so that it goes deep in your mind. You just need to understand the intuition. You don't need to focus on the code, just understand there are 2 steps. One step is log n and second step is n. So let us say this was my list. Again, I'm using the same example. So let's say this is 1, 2, 3, 4, 5, 6, 7, 8. So what will happen? 38, 27, 43, 3, 9, 82, 10 and 5. So let's say this was my list. So how do we do that? First step, if you remember, it was split. So how many splits will be required? There are total 8 elements. So 2 raised to the power 3 is equal to 8. It means 3 split will be required. So first of all, you will split from here. Okay. So what will happen? It will become like this. 38, 27. So 38, 27, 43 and 3. And this will become 9, 82, 10 and 5. Okay, this is your first split. Now, so this was your first split. Now you'll do the second split. What will happen in your second split? You'll split from here. So it will become 38, 27, 43 and 3. Okay, and this will be your, so this will be your 9, 82, and there will be another list of 10 and 5. So this was your 10 and 5, let's say. Okay, now you will do the third split. What will be your third split? You will split from this center further. So it will become 38, 27, it will become 43, 3, 9, 82, 10 and 5. Okay, you have sorted this. Now because your all splitting is done, now step comes to merge back. Okay, now step comes to merge back. So what you will do, the same order in which you came down, you will go up. So you will first of all club these two. Okay, you will club these two, you will club these two, you will club these two. Okay, now you will sort these things. So what will you will get after sorting? You will get 27, 38. Okay, and so you will get something like this. And once you go back from here, you'll get 3 and 43. You'll get 9 and 82, and you'll get 5 and 10. Correct? So this is how you have sort. Now you're going back. So let's do that one thing. Let's go down here rather than going up, so that it's clear, it's easily visible. So this was 27, 38, 27, 38. Remember, you are merging and sorting. Both things you are doing parallelly. And how the sorting happens, I just explained you a few minutes back, right? So you start comparing all the numbers individually, and you create a new list, and you start storing in that particular list. So that's how the sorting happens. 9, 82 and 5 and 10. Okay, this happens. Now what you will do, you will combine these two lists. Remember, you cannot combine this with this directly. You have to combine in the order in which you came down. The order in which you came down, in the same order you have to go up. So now once we do this, it will be 3, 27, 38 and 43. And you will simply do this. And here what will happen? It will be 5, 10, sorry, 9, 10 and 82. This becomes your, and the final will be the single list after merging all this and sorting all this. It will be 3, 5, 9, 10, 27, 38, 43 and 82. So this is done. It was done. Remember, n first step is log n, second step is n. That's why combining it becomes n log n. Correct? And now let's just see the where does it stand as compared to other algorithms on the chart. So if I just create this, my initial data set which we had. So if you remember, this is my O log n, which we discussed. This is log n. This is my n. There lies my polynomial complexity. So let's say O n square, n cube, whatever. Okay. Here lies my exponential, which we discussed earlier, which is the worst time complexity. This particular algorithm, n log n, it lies somewhere around here. So this is worse than polynomial, linear and all that, but it is better than exponential. But remember, for merging algorithms, this is the merging operation. This is the best. There is no better time complexity than n log n. So I hope you understood this particular video. Don't stress up much. If you don't understand everything, it's fine. I just wanted to give you an idea that how things work, what all things you are going to face once we start doing algorithms. This was just a refresher for that. We will be discussing a merge sort algorithm in more detail with coding once we start the algorithm part. So thanks for watching this video. I hope this explanation was clear. If you don't understand anything, please comment below, and I will see you in the next video.